Okay, welcome everybody. I just shared my slides, so hopefully you can see them. If not, then please let us know either via the chat or by sending an email to info@westgrid.ca. So my name is Alex Razumov, and I'm a visualization coordinator with WestGrid. This is going to be a fairly high-level introduction to WestGrid and Compute Canada. I'm not going to go into any technical details of working on our systems, just a high-level introduction for those of you who are not familiar with WestGrid and Compute Canada. I'll talk about advanced research computing in general, what it is, who uses it. We'll give an overview of WestGrid and Compute Canada, how to get an account with us, the services that we provide, and briefly touch on our training programs. Okay, so what is advanced research computing? We get asked this question quite a lot, and there could be many answers. The simplest answer is that it is research computing beyond your individual laptop or desktop. If you need computing power, computing resources beyond a single PC or single workstation, we can provide these for you. Traditionally, this has meant high-performance computing, or HPC, which is running very large simulations on a parallel cluster or a supercomputer. This was and still is a very important area for people primarily from traditional computational sciences, such as physics, chemistry, biology, maybe earth sciences, engineering, where you would see large numerical simulations. In recent years, we expanded our services to other areas, such as cloud computing, which is providing virtual machines that researchers manage themselves and where they can install any software they want. And also research data storage and management, perhaps for long-term storage, archival storage, or large file transfer or data sharing with other researchers and the wider community, and also data analysis and visualization. Most importantly, we provide not only computing resources, but the services in support of research, ultimately to enable excellent research and to accelerate scientific discovery. Compute Canada is a national nonprofit distributed organization that provides all of these resources and services in collaboration with its regional partners from coast to coast. Compute Canada provides resources and support independently of the geographic location of equipment or researcher, and any academic research in Canada can use our services free of charge. Compute Canada has 35 member institutions, so these are Canadian research universities and research hospitals. And our funding, both hardware and operations, comes from the Canadian Foundation for Innovation, CFI, matched by the provinces, institutions, and other partners. I already mentioned our regional partners, so there are 4 of them from coast to coast. WestGrid from BC to Manitoba, the 4 western provinces. Then there is Compute Ontario, there is Calcul Quebec, and also EastNet in the maritime provinces. These regional consortia work with individual universities, have staff at most partner institutions, and manage local hardware, and also they coordinate local activities such as training and staff management. Compute Canada, on the other hand, has more of a leadership role, coordinating national services, procuring high-performance computing systems, and securing funding. And directors for each region, along with the Compute Canada CEO, form the management committee, which is the decision-making body for Compute Canada. Compute Canada is currently in one of the biggest advanced research computing renewals in Canadian history. So starting last year, Compute Canada has used funding from the CFI to replace aging systems with 4 new large systems that consolidate resources and centralize services. This map shows Compute Canada's 35 member institutions across the country, and also the 4 sites that were selected to host the new national systems. I will talk about these sites in a few minutes. What you don't see on this map, scattered across the country, is our network of about 200 team members that provide on-campus support to researchers. So our users can easily access the resources and expertise they need, no matter where they're allocated in the country. Over the course of the next year, a 5th national site will be brought online. Each of the new national sites offers an expandable and modern data center with highly qualified personnel. Operations of the new systems are delivered through national teams, drawing talent from across the country. The first new national system called Abutus at the University of Victoria went into production exactly 1 year ago in September 2016. And it is an OpenStack cloud system with emphasis on hosting virtual machines and other cloud workloads. Its virtual machines allow users to easily configure their computing environment to fit their needs, and they can use, for example, Abutus to build online portals or platforms, or handle data scraped from the web, or run on-demand visualizations, or perhaps share their work via portals with team members and a wider community. The second system, CEDAR, is located at Simon Fraser University and is one of Canada's most powerful academic supercomputers. To give you some perspective, CEDAR has more computational power than the entire fleet of Compute Canada's 50 aging legacy systems combined. CEDAR is an HPC cluster for general-purpose batch-oriented computing, including running large parallel simulations, launching multiple serial jobs, and for data processing with 5 petabytes of parallel storage. Currently, it has 27,000 CPU cores and almost 600 GPU cards. And over the next year, CEDAR will be expanded to about 66,000 CPU cores. Gram is another general-purpose cluster located at the University of Waterloo. By design, its setup is very similar to CEDAR, and it is of a similar size with 33,000 CPU cores and over 300 GPU cards. Both CEDAR and Gram went into production 3 months ago in June 2017. And already many Compute Canada users have begun to move from the older legacy systems over to the faster and more powerful CEDAR and Gram clusters. Of the general purpose cluster in the new Compute Canada fleet, Gram is currently the largest in terms of the total CPU core count, second only to the large parallel cluster system called Niagara that's going to come to the University of Toronto this fall. Niagara will have roughly twice the core count and will be a balanced, tightly coupled high-performance computing system designed primarily for very large parallel computational workloads. All national systems have a common login for which you use your Compute Canada account, and they share a single national issue tracking ticketing system. Overall, there was a great deal of coordination between the sites to have a uniform setup across the clusters. And I should also mention that the new national storage infrastructure is coming online, and it will have up to 60 petabytes of disk space, and there's also object storage that is coming online later on this year. So what is WestGrid? WestGrid is Compute Canada's regional partner organization spanning British Columbia, Alberta, Saskatchewan, and Manitoba, the 4 western provinces. And WestGrid brings together computing facilities, services, and a network of technical experts to work with researchers. WestGrid has 16 either member or partner institutions across the 4 western provinces. And we have a strong relationship with each site, providing personnel, equipment, collaborative and visualization facilities, and training to each partner university. WestGrid has 53 team members that are employed in system administrator or user support roles at various partner institutions through the CFI's Major Science Initiatives, MSI for short, project. These team members are part of Compute Canada's nationally distributed network of 200 experts that I already mentioned, and they are WestGrid's main strength because they were close to the researchers and provide us with a unique understanding of the Canadian research community. Our user community is constantly growing, and we are actively seeking ways to introduce advanced research computing to new users in all disciplines. This chart here on the slide shows the number of faculty that use WestGrid per research discipline. I already mentioned traditional computational sciences such as physics, engineering, and so on. And we also have an active involvement with the humanities and social sciences community, with a full-time digital humanities expert and several team members working on related projects. Compute Canada accounts are free to any academic researcher in Canada, whether they're faculty, postdocs, or students. To get an account, all you need to do is register online in the Compute Canada database, CCDB for short. And the account creation process must be initiated by the principal investigator, who is a faculty member at the Canadian University. And once a PI is registered, his or her team members can register using the PI's designated account number to be added to his or her team as group member. So right now, the account approval takes approximately 1 or 2 business days. Once you have a Compute Canada account, you can immediately access the 3 national systems that I already mentioned, Abuto, Seed, and Gram. And if you want to access legacy WestGrid systems managed by WestGrid, then you need a consortium account, a WestGrid consortium account, which you can also apply for through the CCTB webpage. Simply click on the checkboxes for the consortium account that you need. All documentation for the new national systems can be found in our wiki, docs.computecanada.ca. Things like system details, user guides, and so on. A few months ago, we recorded about a dozen short introductory videos on the basics of getting a Compute Canada account, using Seed and Gram classes, running jobs, software environment, best practices, and so on. And these are available on our Compute Canada YouTube channel, so please go and check them out. These resources should also help you get started using the national systems. And if you have any problems or questions, simply email us at support@computecanada.ca. Now I will talk a little bit more about the resources and services that we provide. As I already mentioned, if you have a Compute Canada account, you can log in into the new systems and start using them right away. About 20% of all resources on Seed and Gram are available via the default allocation, or what we call the Rapid Access service, that allows users to simply log in and start computing right away. Many research groups can meet their computing needs through using only the Rapid Access service. If they need to use more resources, they can apply for them via the Resource Allocation Competition, or RAC, that takes place once a year in the fall. And the applications are evaluated based on their technical feasibility and also scientific excellence. And if successful, recipients have priority access for use of their allocations. So RAC allocations take about 80% of resources on the national systems. In some cases, I already mentioned that RAC applications happen once a year. In some cases, the schedule for project would not fit into the RAC schedule. For example, a new faculty arrives, or you might have a special opportunity to make a significant scientific breakthrough that you could simply not have anticipated during the regular RAC application period. So in those cases, users can submit an out-of-round application at any time. We have several hundred packages, software packages and libraries installed on the new national systems. And you can find the full list in our wiki documentation. So this list you can filter by system or by software category. And if there is anything that you need and you don't see it in the list, please let us know. And if this software package or library can run in Linux inside the fast environment, we'll be happy to install it for you. I already mentioned the cloud system Abutus at University of Victoria. So together with a few other systems in Compute Canada, it forms the Compute Canada Cloud. And the main feature of the cloud is visualization. So instead of scheduling batch jobs that run natively for a relatively short maximum time on the cluster, in a cloud system we manage virtual machines, instead of which a researcher can do pretty much anything they want. So they can install their own software, they can be root, and so on. And running in the cloud is useful if you need a virtual machine for launching a persistent service, for example, a web server or any other type of server that is listening for incoming requests, or if you want to control your operating system or the software stack. Another service that we provide is a Dropbox-like storage called OwnCloud. To use it, you will need a WestGrid account, since this service is provided by WestGrid, and it's hosted by WestGrid, and it is fairly easy to use. So you can download a desktop client or mobile client, or use OwnCloud inside a web browser or from the command line. And it is useful for online storage and sharing of files with colleagues. Another service that we provide is called Globus, and it's used for moving large data between any two locations, or as I call in Globus, between any two endpoints. So typically one of the endpoints would be a Compute Canada or a WestGrid system, and the other endpoint would be another Compute Canada WestGrid system, or maybe another computer, your own laptop, or any computer on which you can install the Globus endpoint software. And the advantage of Globus over other file transfer mechanisms is that it's fast, and you don't need to stay online to complete the transfer. So you simply initiate it, typically via a web browser, and then you can log out or even close your laptop. And Globus will automatically restart transfer if it fails for any reason. and it will notify you by email if, when the transfer is finished. Federated Research Data Management Repository is FRDR is a collaboration between Compute Canada, College Network, and the Canadian Association of Research Librarians, CAL for short. This repository will address a long-standing gap in Canada's research infrastructure by providing a single platform in which research data can be preserved, discovered, shared, and importantly cited. So the platform's federated search tool will provide a focal point to discover and access Canadian research data, and it will also comply with the institutional and funding agency data management requirements. The estimated production service for this service, estimated production date for this service is late 2017 or early 2018. We also have a video conferencing portal and gateway and provide video with Y accounts to WestGrid users upon request. These can be used for distance research collaborations, for meetings, for remote PhD defenses, and also we use them heavily for teaching webinars like we are doing right now. I listed some of the services that we provide. The goal of these services, along with our infrastructure and expert support, is to help researchers produce faster and better results. So for example, if you deal with a lot of remote sensing data, like in this slide, in this image by the Natural Resources Canada, it will help to have more computing power to process these data sets. Since 2010, more than 33,000 scientific publications have cited Compute Canada or one of its regional consortia. And we know that research that has used Compute Canada resources has on average a high field-weighted citation impact in all disciplines. We can actually measure this with the largest effect in emerging digital fields and multidisciplinary areas. These are just some of the examples of the kinds of researchers that make up the WestGrid and Compute Canada user community. So WestGrid and Compute Canada resources are used by researchers in pretty much all disciplines, working on projects of all scopes and sizes. Starting this month, September, WestGrid is launching a series of training events to help researchers start using ARC, Advanced Research Computing, or to advance their existing knowledge and skills with ARC tools and resources. All details about these training sessions can be found on the WestGrid website, either in the events listings or is user training section. This year, for the first time, we ran this past summer, we ran two 4-day-long summer schools, one at UBC and one at the University of Saskatchewan. That in total attracted 220 participants and were very, very successful. So we are planning to organize these summer schools, perhaps at different institutions every year. And if you have a request for training in a particular topic or would like to see an in-person event offered at your institution, please send us an email to info@westgrid.ca or perhaps support@westgrid.ca, and we can make it happen. So in these slides, you see the training events that are running starting this month. These are designed to help researchers get started using our resources, such things as introduction to Linux, parallel programming, submitting jobs, moving data, visualization, and so on. And if you need more information, here are some channels you can use. You can submit any request either to WestGrid support or to Compute Canada support, and both of these will go to our ticketing systems, and they will reach the right support people. Okay, so this is the end of my presentation and the end of the slides. Thank you very much for attending.